So here we are looking for the DC switches, and when we talk about the data center switches of the Cisco family, Nexus product line is very important. Okay, like how you have the catalyst for the campus LAN environment, enterprise environments, Nexus is predominant in the DC, and Nexus has its product lines. So there are multiple series, as in the 9K, 7K. Let me write here. So we have the 9K, 7K, we have the 3Ks and 2Ks. Now this is what we'll be discussing in the class. There also used to be the 5K, which is the end of life now. Yes. And that's one of the reasons why people are moving towards the 9K, 7K model or into the ACI model. Apart from this, we also called a specific node, it's called as a fabric interconnect. Those who are familiar with the UCS environment, the fabric interconnect is treated as a Nexus 6K for the reason that it is nothing but the 5K plus the UCS manager. So these are some of the switch varieties that we will be looking into, and we will start with the hardware first. And major focus will lie on the Nexus 9K. Or I mentioned that the 9K is what is the major component of the ACI environment. Okay. So what do we expect from the data center switches? We expect it to have low latency, high throughput. Then, of course, to support the data center technologies, we wanted to support VXLAN, OTV, VPC, and some Nexus models. Now, the 5K used to support FCOE also, which is a fiber channel over Ethernet, so that the 5K could actually handle both the LAN and the SAN traffic, the FC traffic as well as the Ethernet traffic. So those are some of the requirements that we expect out of the data center switches, and the Nexus product line is very good for that. So when we talk about the Cisco DC products, the major focus is on the Nexus. And apart from that, we also have the MDS category of switches. MDS is multi-layer director switches, which primarily focuses on the storage area network. Nexus primarily focuses on the Ethernet standard. And for that matter, the requirements are going to be different. The CLI, the operating system, everything is different in these two. If you look at the Nexus, all these models, okay, the 7K, 3K, 2K, and even the 9K, all of them support the NX-OS. Now that's the operating system we make use of in the Nexus platform. Now, apart from that, we also have the ACI operating system, ACI OS, which is used in the case of the ACI. So you either run NX-OS or ACI OS, but not both at the same time. So what I'm trying to say is the ACI is not a subset of the Nexus. In fact, these two are two separate images. So either have this or have the ACI OS. Similarly, the MDS switches, which handle the SAN traffic, primarily have the MDS operating system. The features that is supported on the MDS switches, that is going to be FC based, fiber channel based. Therefore, it will support features like provision of the FC ID and zoning, and what else? We have the fiber channel name server, and we have the device alias configurations, node name, port name, because it's primarily two different types of traffic. Therefore, we have two different types of adapters, switches, and everything to handle that. So these are the different products that we have for the data center from Cisco. And here in our class, we will focus mostly on the Nexus part. Okay. So what do we know so far? Data center switches. Yes. So back to this Cisco data center switches. So what do we expect from the data center switches? First of all, high performance and scalability. It should be easier to scale. And as you scale, there shouldn't be a bottleneck. Now, let me give you two examples. Let's talk about a three-tier topology. The three-tier topology is defined for the north-south traffic. Do you think it is good for the east-west traffic? It is not. The two-tier topology, exactly. It's not good for the east-west traffic. Now we have the two-tier topology, which is good for the east-west traffic. And that's not the only benefit of the two-tier topology. The two-tier topology scales easily. You want more bandwidth, you can add this spine. You want more access port, you can add the leaf. That's how easy to scale it is. Unlike the three tier, if you want to increase the access ports, then increase that VPC configuration, bring in the extra node, have redundancy for it. What is happening at the layer 2? Where do you place your SVIs? Where is the FHRP? No such problems here. So it should be easy to scale. Why? Why should it be easy to scale? Because agility matters. How fast you deploy your environment matters. And that is also the same reason why we want to have the ACI. ACI can configure a large number of nodes at one go. Also, it is good for the automation perspective. You can now automate and orchestrate many things from the ACI because you can make use of APIs to talk to the controller. So scalability is very important in data center because provisioning and deployment of the nodes should be as quick as possible. Benefit number one. Number two, it should be high performance. It should be able to handle decent bandwidth because unlike the enterprise, it's not aimed at connectivity rather than low latency and fast switching. Higher port densities and support faster data rates. Now in Nexus, you will see that the line cards and the fabric modules, we will talk about those hardware in detail. There are two components. They're just directly connected to each other. And when looking at the bandwidth, you will recognize the immense amount of bandwidth they support. Because we are supporting high bandwidth applications, we want more throughput, more bandwidth, and also higher port density. Look at the switch model. It comes with, we have this 9516, which could support up to 16 line cards. That modular chassis. Many of you mentioned you have been working with the Nexus 7 case. So they are all modular. So the port density is also very high. Now that is one benefit. Advanced features. Virtualization. High speed links. Now we have the 400 gig bandwidth. And on the, there is a Cisco product with 800 gig. Each of the port is 800 gig capacity. Now here for the switches, the maximum what we deal here is only the 400 gig. We will not talk anything about 800. We do have models, Nexus switches, where each port is a QSFP double density 400 gig capable. You can handle the breakout cables, but each port is capable of handling 400 gig bandwidth. Virtualization, network virtualization, data center interconnect technologies basically. So we talk about VXLAN, OTV, and apart from that, DCB is to facilitate the FCOE only to alter. It's called as data center bridging. Some parameters which should be altered in order to handle both the FC and the Ethernet traffic. And of course, power and cooling is very important. There is a special feature in Nexus which we'll talk about. It is the first model to have no mid plane, and because of which it's the airflow is good, not hindered, and therefore the power and cooling requirement is very less for the Nexus compared to other models. So this is what the DC switches is for, and this is what we're expecting the DC switches to satisfy with. We already discussed about this classification. We have the MDS, we have the Nexus, and across these Nexus, we have these models 9K, 7K, 3K, and 2K. 2K is not a switch. It is called as a fabric extender. It doesn't have the switching capacity, which means FX is only to provide additional ports, provide extension of the ports. You can that's an extended line card with no switching capacity. So FX has to have a parent where the switching is usually done. So that is a port extension line card. Nexus 2K. We'll also talk about that. Nexus 3K, 7Ks. While talking about the 7Ks, we'll focus on the VDCs. And now let's drop down into the Nexus 9K series. First, let's start with the 9500. So here we are looking at the Nexus 9500 series. And from the 9500 series, the one thing that you can notice in common is it is a modular type. And this one, the 9300 series, that is fixed port. This is a primary difference we need to understand between the 9500 and the 9300. So because it is modular, we know what is the benefit. The benefit is because we can get to select the line cards depending upon our requirement. We can also scale as per the requirement. Yeah, we can increase the number of line cards as how you want to be. And that's the benefit of the modular. The 9500 series is usually used as spines. And the 9300 series are usually used as leaves. But there are some heavy models on the 9300 such as 9316, which is all 16 ports of 400 gig. That can also be used as a spine. So it basically depends upon the requirement. Then here we are looking at the 9300, sorry, not the 9300s, it's the 3Ks, Nexus 3K and the Nexus 2K, which we discussed as to be the fabric extenders. So these are some of the product lines. We already discussed something about the product lines, like the 7Ks and also the fabric interconnect and the end of life product, which is the 5Ks, many such things. Form factor, yes, discussed again. Now what you're looking here is a 7700 series and chassis type and the fixed port type. Operating system. So far we have come across these three different operating systems. We see that there is this MDS, and then there is Nexus, and then there is ACI operating system. First, what is this Nexus operating system? Nexus is actually Linux based. Therefore, it has native support for Python. One thing. Therefore, since it is Linux based, it is also containerized. Every process that happens, there could be like 80 to 200 processes running on each of those switches. Those are running in containers. Therefore, the failure of one service, one process is not going to impact another process. Also in Nexus, now these features actually have names. Okay, I just don't remember those names, but these features have like how we call VXLAN. That's a name to define a certain feature, correct? Similarly, what I'm saying is actually a feature. It does have a name, but I'm only telling you the concept of the benefit of the NX-OS. And it performs side by side simultaneous execution of the commands in the NX-OS. So, which means for one process to complete, it need not wait to start the other process. It can simultaneously run threads. So these are some benefits of the NX-OS. And in NX-OS, I spoke about these containers. And I said one process is not going to impact the other process on failure. Now, when a particular process fails, that process can be restarted again with the same runtime configuration. There is again a feature we will be talking about in the upcoming classes. It's called as persistent storage service. The NX-OS have it. Now, this is actually handled by the system, the controller. It's not coming to my name. Supervisor. Yes. So the soups maintain the PSS. We will eventually talk about it. First, we will learn about the supervisor in detail, what it has, how it takes the active standby role, and what happens during a failover. Then eventually we will learn about how the PSS is handling the failure of each of the process. The PSS has something to do with the NXOS. That's why I brought it here. But we will get to it. So NXOS, like we discussed earlier, is the operating system on the Nexus, and MDS OS is the multi-layer director switches. NX for the Ethernet, DC, and SAN OS or MDS operating systems for the storage area network. Here are some of the features which comes with the NXOS. As you see, FCOE, ISCSI, they are the storage protocols. PTC, VRF, that's what we have on the NXOS because it's requirement on the DC side. Similarly, NXOS offers DCI, DCP, OTV, VXLAN. And to talk to the NXOS, you can make use of the CLI, the GUI, and also the API. Here also, like if you remember, I mentioned that to talk to the API controller, you can make use of these three methods. Similarly, the NXOS also, you can employ these three methods. CLI, you can log into the console, you can get into the CLI and work with it. How do you have the GUI? Where is the GUI for the NXOS? Where is the GUI for the NXOS? You can have, if you do the, there is a feature called NX API. When you enable that, you can access the management IP on the HTTPS interface. And you can use the same interface to build your APIs. This NX API feature is awesome, guys, because you can provide, let's say, you give a certain command, okay? Let's say you say feature OSPF. Now this is NX CLI based. The NX API feature, okay, that page, that sandbox will convert the feature OSPF, which is NX CLI based, into Python, JSON, XML, depending upon what you want to be. So you can build your scripts with the help of this NX API feature. And that's not the only case. Now there are, things like Ansible, Puppet, Chef, with which you can talk to the NXOS. Now that is also one way of communicating with the NXOS nodes. So this is something about the Nexus operating system. Finally, the certain models of the 9500. So the 9500 has three models, okay? Only three models. One is 9504. The second one is 9508. And the third one is 9516. All three are modular chassis type. The primary difference between them is the number of line cards they have. If you look at the naming convention, 95 denotes the series, 04 denotes the number of line cards they have. 4 line cards here, 8 line cards here, and 16 line cards here. So here we are looking at a 9500 modular chassis. Here what you see are line cards, and this is the soup. There are two supervisors. We will learn about the supervisors eventually. To give you an intro on this, the supervisors, one of them is active and the other one is a standby. And both of them have to be the same models. You cannot mix match. There is A plus B plus variety, but what you have, you should have for both of them on the same type. Then apart from that, you also have the redundant power supply units, hot swappable redundant power supply units. Now this is what you have on the front side. On the back side, so the power cables, everything come on the front side. On the back, you have the fan, and there is something called system controller. We will explore the hardware. Now, I do have the picture. See this. So this is the back side for the 9504. This is a system controller. Here are the fan trays. And the front side, you have the line cards, supervisor, power supply unit. Behind the fan tray, okay, this is the front, right? This is the front. This is the back. The fan trays are also swappable. And if you pull the fan tray, behind the fan tray, you will see that you have the fabric modules. The fabric modules are present behind the fan tray. So that component is actually hidden here. The line cards and the fabric module just sit at right angles to each other, orthogonally placed. So the fabric module will be like this, and the line card will be like this. So there are connecting pins. They directly connect to each other. Now, let's imagine there are 3 line cards. So we have these models 9508, 16 chassis. So the 9508 is this one, and you have the 9516. What is the major difference? The number of line cards. How about the supervisors? Irrespective of whatever model, you always have 2 supervisors. The number of power supply units may increase. For this, as you can see, it is more. For I think for the 98, this one 9508, it is 8, and for this one it is 10. So this is a physical difference on the front end. From the back, as you can see, so this is 9508. The fan, number of fans in the fan tray. So for all the models, you can have up to 3 fan trays, and each of those tray can consist of maximum 3 fans. And for the 9516, it is 6 fan per tray. So for one vertical will consist of 6 fans. I have the image. See? So we have 6 fans per vertical in the 9516, and you have 3 fans per vertical in the 9508. And behind the fans is where you have the fabric module. So as you can see, we have the fabric module here, just right behind the fan. And apart from that, the system controller is very important. What it does is it takes away the management of the physical components from the supervisor. Maintenance of the fan comes under the system controller. Maintenance of the temperature, fan sensor, system controller. Maintenance of the power, system controller. So some physical functions are offloaded to the system controller for better performance of the supervisor. So these are what we have as components present on the chassis type. So in Nexus, the chassis type, you have three models, 9504, 9508, 9516. All of them have line card, supervisor modules, power supply units, fan trays, fabric modules, and system controller. What scales? There is a line card, power supply unit, and the fan. Also the fabric module. And what is the same across all the models? The number of supervisor modules and the number of system controller. Supervisor modules are in an active standby state. So is the case with the system controller, active standby state. Okay. So we discussed about this. 9516. Yes. So the scale is only the difference.